So today we're talking about getting started with the ELK stack for logs and metrics. And I am Dan Resigno. I work in product marketing at Elastic. And before that, I was in ops for about 50 years, I think. It feels that way anyway. Housekeeping. If you're watching this live, we have an IRC chat via Freenode. There's a link in your invite email if you would like to join that. There's already about 80 people in there. And you can ask questions in there, give comments, etc. If you're watching a video of this, set it to high resolution. And you can ask questions also at discuss.elastic.co. That's where we have our forums. So, obviously you can't use the IRC, but you can ask questions at Discuss, and we can answer them there. The slides and the video will be available afterwards, usually in a day or two. So, in the invite or the marketing for this, we talk about the ELK stack. ELK stack, Elastic stack, it's all the same thing. The original three parts of ELK are Elasticsearch, Logstash, and Kibana. And all three of these are developed by Elastic employees and open source contributors. I'm the pretty face presenting this today, but we owe it all to the developers and the contributors who've made this all possible. There's a bunch of the Elastic developers in the chat in IRC today, so you can ask them the hard questions and they'll answer them for you. And then we'll take some questions at the end and answer them, during the video. We call it the Elastic Stack instead of ELK because there's so many more parts now to the Elastic Stack. Beats, which are the lightweight shippers, application performance management or APM, site search, application search, etc. I'll show you more now in these slides. All right, so this is the heart of the Elastic Stack: Elasticsearch, Kibana, Logstash, and Beats. Elasticsearch is the core of what we do. It's a super fast search engine that's used to store, search, analyze, roll up data, etc. Kibana is the visualization and management interface. You'll see a bunch of Kibana today during the live parts. Beats and Logstash are for ingest. We'll use Beats today, and I think you'll love the Beats modules that we have for Apache, Redis, Nginx, and the operating system. There's a whole bunch more modules. Those are the ones that we'll be using with the demo application. I'll talk more about modules in a sec. So up top, we have solutions. We build curated UIs for various things like logging, metrics, and APM, and we add in specialized apps where we need them. I won't go into the solutions today other than logging and metrics that we'll be concentrating on, but there are lots of videos and web pages about these at elastic.co, so you can learn more there. Deployment, it's up to you. You can use Elasticsearch service in Elastic Cloud, and we'll manage that for you. If you have a centralized IT department that wants to manage Elasticsearch deployments, we have Elastic Cloud Enterprise, which runs on your hardware or within your cloud infrastructure, and you manage it. And it looks a heck of a lot like Elasticsearch service in Elastic Cloud because we take the management tools that we use to manage Elasticsearch service, and we put them into Elastic Cloud Enterprise. So you get the a very similar experience, and you get things like one-click upgrades and things like that. And of course, it's standalone. You can download all the code and run it on your own hardware. So if you go to elastic.co/start, there's a ton of information on all the choices. And you can sign up for a free hosted trial using Elasticsearch service there also. So I mentioned modules, right? And you see them in the yellow there, and I stretched it across Kibana, the visualization, Elasticsearch, the search engine, and Beats and Logstash. Because although the modules ship with our ingest products, bits and pieces of them are put in the various other layers, right? So with the module, you get all these great things, right? It's prepackaged 0 to dashboard in 5 minutes goodness, I like to say. You get the configuration of where to pick up the files. So, for example, the Nginx module knows that Nginx logs on Linux are in var log Nginx by default. And, they're named access.log and error.log. And you get the parsing. So the modules know that a particular string will be the timestamp, and then there'll be a delimiter, and then the IP address or things like that, right? So the parsing pattern is part of the module. The index template, how we index it and store it in Elasticsearch. There are saved searches, visualizations, dashboards, and machine learning. And we'll look at those during the live demo. All of this comes with the modules and get deployed when you deploy them. All right, so we talked about ELK and why we call it the Elastic Stack, and everybody should be content, just like our ELK on the screen. So let's talk about the problem, right? If you work in ops, you've got tons of logs, you've got tons of hardware, or if you don't have the hardware, then your cloud provider has the hardware. And more, you've got sensors. We have customers that manage fleets of vehicles, and each one of those cars or trucks is sending a bunch of data in, so that the maintenance can be kept up on them and things like that. You can tell which customer is using which car for a car rental business, things like that. So this generates a ton of data, and it's all in different formats, and it's coming from all different parts of the world, so the time zones are different. It's a lot to manage. All right, so we're generating a ton of logs. You can see some poor person is tailing these and grepping. The greps are showing up in red. We've got a bunch of numeric data. This is top, but it's the same data that you get through any of the metrics tools. So if your history looks like this, right? This was my life, right? I worked I worked for the phone company, and I'd get pinged by the operations center. I'd pop open a script that would SSH to 30 or 40 or 50 boxes, and then I'd tail minus F the logs and try and convert the timestamps. Working like this stinks. It's okay for 2 or 3 boxes, but beyond that, it's a hassle. So wouldn't you rather have something nice like this, a visualization that represents all of your logs and metrics? The logs and metrics are still there. They're all ingested into Elasticsearch, but we build these visualizations on top of the logs and metrics to give you a visual indication of what's going on. So here we can see this is the Nginx dashboard, right? So we can see where the hits are coming from. And we use a plugin called Ingest GeoIP. I'll show you how to enable that when we do a deployment to convert IP addresses into latitude and longitude. You see the response codes, right? Green are 200s, yellow are 300s, red is 400s, and purple, there aren't too many of those, are 500s. We see the errors over time. We see what pages are most popular. So if you see something pop up there that's a page that doesn't exist, for some reason people are hitting your website with a bad URL. So you'll see a spike in the errors in the 404s, and you'll see something strange on the top pages. You can see the data volume. And the bottom right, we've got the operating system breakdown and the browser breakdown. So all of this is an out-of-the-box dashboard that comes with the NGINX module, and we'll see more of that in a bit. So going a little bit deeper, this is a machine learning visualization. You see those red and orange dots that fall below the line. Things that fall below the line are typically difficult to catch visually. If there's a big red blob or a spike in a chart, we see it. If it's a little bit below or even a lot below the baseline, our eyes tend to ignore it. But machine learning doesn't care if it's above or below. It cares if it's unusual. So machine learning would pick this up. This is an NGINX machine learning job, and I'll show you some of those live in a few minutes. One big thing that this does is it relieves you from sitting there and watching the screen, right? Let machine learning watch it for you, watch the data for you, and send alerts to you from the Watcher application in Elasticsearch. And speaking of watches, right? This is a watch that I configured, when we cross a threshold, send me an alert, right? So it gives you some text, and you'll see one with a link in an email that we can click through to get to the screen. In the title, we talked about logs and metrics, right? This visualization combines logs and metrics. The green line and the blue line are the 95th and 75th percentile, respectively, of I think this was response time when I created it. And the vertical red lines with the little hearts, those are annotations, and those are from logs, right? So green and blue are metrics, and the red annotations are logs. So I created this visualization so that I could track performance and notice with the annotations when I scale up or down a deployment in a Kubernetes cluster. So this is combining logs and metrics within a single widget. All right, so to get to the solution, we need all kinds of things. We need machine learning. We need a fast back end that gives us real-time alerting. We need a lot of scalability. We have customers bringing in tons of data at a very high rate, and they need to know what's going on right now, right? So we need all of these things, and luckily, Elastic has all of this. So we talk about speed, scale, and relevance. This is why Elastic is different, right? So speed, right? The Elastic Stack can find matches in milliseconds with even the largest set of structured or unstructured data set. It's a big search engine. It's not a database, it's a search engine. So everything is fair game for searching. So we can handle real high volumes of data and high volumes of searches. Scale. The stack scales horizontally and massively. We can subdivide search indices into what we call shards, which allows them to be placed across machines so that the load can be spread out across machines. I want to point out that when we do scale up, the experience for you, the developer, or you, the user, is the same as a person who's running a single node on their laptop. All of the hard work of dividing things up is done behind the scenes, so you don't have to worry about where things get placed. Right? Relevance. It's one thing to do a search and another thing to return relevant results, right? If you search for something in some search engines, you'll get 50,000 hits, and the first 45,000 of them might be junk, right? But we use multiple analytic techniques to determine the similarity between your query and the stored data so that we can generate relevant results. So speed, scale, and relevance. All right, the demo system. let me just show you what we're using here. Okay, so it's a simple guest book. If any of you are familiar with Kubernetes, in the Kubernetes docs, the first tutorial is building this PHP-based guest book. Right, so you type in a message and hit submit, and it gets pushed into Redis. Made up of Apache, PHP, and Redis as the back end. You'll see some gobbledygook. I have a load generator that'll run later when we're looking at the data that throws stuff in from lorem ipsum. So very simple application, but it's enough to generate data, and we can use some of the modules that ship with FileBeat and MetricBeat to visualize that. Let's see, Apache PHP Redis. Let me go back into full screen. Okay. And so what are we getting out of Apache PHP and Redis, right? We're getting the operating system logs. We're getting the operating system metrics. We're getting response time and DNS metrics. We're getting Redis logs and metrics and Apache logs and metrics. They're going into Elasticsearch and visualized in Kibana. Again, architecture, right? We can use cloud where we manage it for you, or you can do exactly the same thing and send it to a local Elasticsearch in Kibana. I'm going to show you cloud today. All right. So deployments. I'm already logged in, so it shows me my deployments. But if you sign up for a trial, you will get a screen that says, looks like you don't have any deployments, let's create one. And you get to the same place, right? So these are the two deployments that I'm going to be using today, but let's create one. So webinar demo, right? And you can choose AWS or Google. Pretty soon there'll be more choices, I bet you. All right, so I'm going to say Google, and you choose where you want it deployed. Iowa's fairly close to me. It defaults to the latest version, or you can restore from a snapshot from another system. So these are new choices. If you've looked at this in the past, a few months ago, we added in what we're calling dedicated node types. So you can customize the deployment based on what you're doing. If you are ingesting a ton of logs and you're going to keep them for a long time, then you probably want to use a hot warm architecture, right? So you have really fast responses for the past few days or week of logs, and then a slower response for stuff from 4 years ago. And the reason that you would do this is because the warm nodes cost less, right? So you can reduce your costs and meet your requirements of your use case. I'm going to use IO Optimize today, and I am going to customize the deployment. All right, so notice that it says that's $178 a month here. All right, I'm going to customize the deployment because I want to enable machine learning. Right now, we're giving you a 1 gig machine learning node at no additional cost, right? So I enabled machine learning, my price stayed the same, right? So you can use machine learning and not pay extra for that hardware, right? So I've turned on machine learning, and I also want to manage the plugins. If you accept all the defaults at the first screen, these two plugins will be selected for you out of the box, Ingest GeoIP and Ingest User Agent. A few minutes ago, I showed you a picture, and it had a map of the world and lit up where we were getting hits in Nginx, right? So that's part of the Ingest GeoIP processing. So I want that, and I want the user agent because I want to know what browsers my users are using when they connect. And the modules that are related to web front ends, like the Apache 2 module, the Nginx module. Those decode the string, the browser agent string, and make a pretty graph, right? So I want those two. And the rest I'm going with the default. So I click on Create Deployment, and it brings me back. So in a few minutes, there'll be a new deployment. We're not going to use that deployment because I've already got one fired up. Um, all right, so demo time. Let me switch over to the walkthrough tab. So here I've embedded Kibana and a SSH terminal here so that you can see everything. Let me go full screen. There we go. Okay. So this screen here is called Kibana Home. This is a great place to get started. If you follow those instructions I mentioned earlier at elastic.co/start, you'll have Elasticsearch and you'll have Kibana deployed. The next thing you want to do is get data in. So when you open up the Kibana window, this is what you'll see. Add data to Kibana. You have choices. You can load a sample data set, or you can load real data. Let's load some real data. So we're going to add some log data, and it pops up a selection of the different modules that are available for FileBeat. There's a whole bunch more, but these are the ones that we've got featured in the Add Data page. So I mentioned earlier, our application is made up of Apache, PHP, Redis, and we also want the system stuff. So I'm going to click on Apache and I'll follow those instructions, but I'm also going to enable the Redis and system modules. And you get a choice. Because I'm on a Mac, it defaulted to Mac OS, but my virtual machine up here where I'm actually deploying is Ubuntu. So I'm going to use the Deb choice, right? So I'm going to grab the Deb. And install it. Okay, so I've got it installed. It says edit the etc FileBeat YAML, right? So here, this is the Cloud ID and Cloud Auth. The Cloud ID identifies where the Elasticsearch and Kibana nodes are, and then the auth is the password for the Elastic user. So let me copy that, and it gives me the path, etc FileBeat. Oops, sudo. And we want cloud.id. Okay, I've already got them in there with data, and that's good. And then we want to enable the Apache 2 module. I am going to also enable the Redis system. So Redis system. Okay, those are enabled. And now we can start FileBeat. Before I start FileBeat, I want to show you a little bit about the config. So Beat modules, and let's look at the Redis one because I have multiple Redis instances running, so I'm using two different ports. So I want to make sure that we're getting the data from both ports. Okay, so out of the box, this would just say localhost 6379 because 6379 is the default port for Redis. I added in last night when I was setting this up port 6380 also. So out of the box, the modules will work great for default installations. If you've done something a little bit different, I guess you wouldn't normally run multiple Redis instances on a single machine, but I did. So I just added it to the array. All right, so we're set there. So it says sudo service filebeat start. Oops, sorry, setup. So we run the setup, and this that module goodness that I told you about, right? So it sets up the index template in Elasticsearch. It loads the dashboards. So right now it's sending a bunch of dashboards up to Elasticsearch service in Elastic Cloud and populating them in Kibana. And then it's going to deploy the machine learning jobs. All right, dashboards are in, machine learning's in. We are good to go. All right, so let's fire it up. Okay, so because I'm old school, I'm going to tail the log file. Var log file B, whoops. Dot 7 maybe? No. Just file B. Okay, so the log file for FileBeat is going to give all kinds of details on what it's doing, right? And I want to look for the string harvest. Right? So 1630, that is now in UTC, right? Harvester started, right? So I didn't tell it where the logs were, but it knows to look in varlog Apache on Linux for access.log and error.log. It knows on Linux, the system module knows to look for varlog syslog and varlog authlog. And Redis, the default is varlog Redis, and then it looks for Redis server star. So it gets the one for the server and the one for the worker node, and those are my harvests. So we're sending data now into Elasticsearch. So let's take a look. Last 15 minutes for FileBeat. So I'm getting data in. And if I want to see which modules are being populated, I can just click on here on the title, file set.module, or I can click on add, and then it modifies the output and shows me which modules are being used: Apache 2, system, Redis, etc. So we're getting data. Let's take a look at our dashboards. So this is Apache, right? And it's showing we've got a little bit of data from a Mac OS node. Let me turn on a load generator so we'll get some more stuff. Sorry, that window is on my other monitor. All right, so we'll generate some data and we'll have more interesting things to look at. All right, so we're getting data there. Let's take a look at the system. we're getting our syslog messages, right? It tells you where the syslog messages are coming from, if it's an application or um, a cron job, etc., things like that. And you've got the logs there, right? So if I click on one of these to expand it, you've got the original log, right? And you've got all of the metadata about that. All right, let's go back to Kibana Home and add some metric data. And we'll choose Apache Metrics and Debian, and it's exactly the same steps. Um, and I've already edited the metric beat.yaml, so let's enable our modules. So we want Apache, Redis, and system. And we want to start up metric beat. Okay, while that runs in, let's switch back here. And look at the Redis status. So we'll take a look at the Redis information for, right? So with Redis, once once we actually have some activity on the in the web application, you'll see which sorry, let me just hit enter there. Which Redis activities are taking a longer time than the threshold. Those will show up at the top here, and the different types of messages here. And then again, you've got the actual messages here in the dashboard if you want to read those. So you might want to dig into a problem here. Let's look at some metrics. Okay, so metric beat has started. I'm looking at the last 15 minutes and we're getting data. We've got 6 connected clients and they're all connected. Nobody's blocked. And we've got the details on the CPU utilization and memory being used, and the versions of the software. System. This is an overview of the performance of the system, and then I can click into a node or a host rather, and get the details. So I can see the network traffic, the memory usage. Yeah, I want you to to realize I didn't configure anything. I didn't tell it what to collect. All of this is pre-configured. Now you can go in and edit what gets collected, but the out of the box defaults are a great start, right? So then I can see which processes are taking the most. So that's interesting. I didn't realize I was running MySQL on my VM. That's from an old demo, and I forgot to turn it off. And it's using the most the most memory. So you never know what you're going to learn, right? So we've got the network traffic in and out. We've got a breakdown of memory and CPU usage, and we've got the high level gauges up at the top. So we've got lots of great information, right? So I've only been demoing for 19 minutes, it looks like, and we've got the beats deployed, we've got data flowing in, and we've got useful information in the dashboard. So I want to go on and dig a little bit deeper and talk about machine learning. I think if you work in ops, uh, you know, dashboards are great, and they're very useful for seeing things visually and knowing what to dig into. But if you've got 10,000 servers or 10,000 Docker containers, um, that's going to be a pretty big dashboard that you're looking at. So you'll want some um, automated processes to find problems and alert you to them. Let's take a look at some information about machine learning. Machine learning uses algorithms to look at the data. It might be looking at metrics that are in the data. It might be looking at counts of records. We're going to look at Nginx machine learning jobs, and we're going to be looking at the number of users. We're going to be looking at the responses that those users receive. So the response codes, 200, 404, 303, etc. Let's get into that. Oh, so when machine learning does find something wrong or unusual, it's going to send alerts. So this is an email that I got the other day when I was setting this all up, and it tells me that the response code job from FileBeat for Nginx has found something strange. The anomaly score is 93. So I had set it up so that only critical anomalies would come through. So when the machine learning algorithm is pretty darn sure that something strange is happening, um, it sends me an alert. 93 out of 100, it's pretty sure that that something strange is going on. And then I can click into the machine learning dashboards to to view that particular anomaly. And then it gives me a little bit more detail. It tells me that the count of 304s is 99, the count of 200s is 99, and the count of 301s is 93. And we'll see how far off those numbers are when we get into the UI. So machine learning. So I've got this set up. I showed you when we were deploying those beats, right? When we deployed FileBeat, it inserted machine learning jobs into Elasticsearch. Now they weren't running, but they were there and available. So it gave us Apache and Nginx machine learning jobs because those were two of the modules that I enabled. So we've got the low request rate job. We've got um, unusual remote IPs with high request rates, and unusual remote IPs with a high distinct count of URLs. So if someone is indexing your website, it might set off the high distinct count of URLs, right? If someone is downloading the same file over and over and over and over again, it might have a high request rate. Um, the three that we're going to look at are low request rate, unusual response code rates, and unusual visitor rate. So why would we look at those three? Let's imagine that I am running a web-based storefront. If the visitor rate drops, then I'm not making as much money as I normally would on this particular day of the week at this, this particular hour. And that might be because, um, everybody's switched over to a different retailer, and it might be because there's something wrong with my web server. Maybe it's returning errors when it shouldn't be. So let's take a look at what we've got. And I want to look, oops, sorry. So this data runs from, what month is this? This is October. runs from the beginning of October to the end of October. So let me go there. Oops, it's looking at the Apache one, sorry. So I want to look at Nginx. Okay, and let's just look at the critical stuff, because this is what I would have gotten emailed about, was the critical stuff. So, and let's also look at the low request rate. So you see here, this is a problem, right? If you're a retailer or anybody that's got a web presence, really, it's a problem, right? So the request rate drops real low on this particular day in October, the 27th, and we want to see why. So let's go back to the Anomaly Explorer. And look at all of our Nginx. And sure enough, we see the red spots on the 27th, which was yesterday, coincidentally. And let's just look at the criticals, like I said a minute ago. Right, so we've got the visitor rate is 21 times lower than it normally would be at this time of day on this day of week. And we've also got our 404s are 8 times higher, right? So we've got some kind of a misconfiguration that's returning 404s when our customers, our users, are trying to go to a particular page. So they're going there, they're getting a 404, and they're disappearing, right? So machine learning alerts us to that. Something interesting is on the 23rd, we had some critical issues, right? We had response codes creeping up. They weren't as bad as they are today, but right? So if I would have had machine learning running and gotten those alerts on the 23rd, 4 days ago, 5 days ago, I would have known something was going wrong and something is causing a problem for my users before it got so bad that people just stopped coming to the website. So something very important about machine learning is it alerts you when things start to go wrong instead of waiting until things are broken, right? I like to call that an early warning period. If you get notified 15 minutes early, that's cool. You can go grab another cup of coffee and fix it. You get alerted 5 days early, you can actually fix it and go home on time and not be working till 3 o'clock in the morning to take care of an issue. Like I said, I come from ops. This is something that really really impresses me because there were a lot of sleepless nights when I was working at the phone company. So now let's take a look at how we would see this without machine learning, right? So we'll go to the dashboards, and remember, I switched into a different Elasticsearch service deployment because this has got the historical data that I loaded, not the data that's being loaded in right now from the things, right? So if I look at the dashboard for the last month, right, I can see that my error counts are really low, right? I have some 300s, right, but few 404s along the bottom. And then I see it spiking up here on the 27th. Now, if I happen to be watching the dashboard, I would have noticed these spikes on the 27th. Would I have noticed this one here on the 23rd? It's not so huge, and it just happens in one time period, right? So I might have ignored it. I might not have seen it. I might have been having lunch when it came up, right? But machine learning doesn't go out to lunch. Machine learning is that employee that comes in and sits glued to their chair 24 hours a day, 7 days a week. So one of the things that we like to say is it catches things that you don't, right? Because you take a break, because you go home at night, um, because you're doing other things, right? So, machine learning, it's very cool. And my opinion, it it makes life better for ops, and I'm all for making life better for ops. Um, let's see. So I showed you machine learning. I showed you the email that I got the other day, right? So Watcher is watching for machine learning. Um, let me show you a little bit about Watcher, right? Um, you can create watches here, right? What have I got? I've got Nginx data, right? So we specify that we're going to use FileBeat, and then we can select a field from there that shows us the time, right? And then we can create the watch. So this one here is a threshold watch. So I would say that if the response time is greater than X milliseconds, send me an alert, things like that. For people who want to see the raw logs, right, in the Discover application, you have access to the raw logs. You can go a little bit further. You can search in here, and let's say I want to just see all the 404s. Let's not search over 2 years, though. Well, that was pretty fast anyway, right? So 75,000 of my 987,000 or whatever it was have 404 somewhere in there. I can look to see where people are coming from. So if I click down on one of these and I want to know what continent they're coming from, I can add that column to the table, right? So I've got North America customers. If I only want to see North America now, I can just click on the plus sign and it filters to North America. So these are records for people coming from North America who received 404s, right? Because I still have this 404 search here. Right, so you still have access to the data, but I would say from experience that you can search this data a lot quicker by coming to the Discover tab than you would be able to if you had to SSH into all those machines and tail minus F grep, right? So it's a lot faster and easier. And you don't have to do the time zone translations in your head because it doesn't matter where these records are coming from. The time zones, the timestamps all get normalized, right? So because it's what time is it here? It's 12:53. If I set this to the last 15 minutes, it's the last 15 minutes in my time zone, and it tells me, it shows me the times in my time zone. These things might be little things, but they're really important to me because they're time savers, and I like to save time. So let me go back to the slides and see what I've missed. All right, we talked about machine learning. We talked about Elastic Cloud. We had a demo, call to action, right? So here's my call to action for you. I want you to try it out. Go to elastic.co/start and sign up for a free trial of Elastic Cloud. You get 14 days to play with it, send in as much data as you want. You can enable machine learning exactly like I did. So you click on customize deployment, turn on machine learning, send in your data and see how it looks. I followed the same exact instructions that you'll be presented with the Kibana Home, and go for it. If you want to deploy it for longer than 14 days, or you don't want to use cloud, just download it and run it on your laptop, or run it on a server in your data center. You can download Mac, Windows, Linux, etc., and run it. You just need to deploy Elasticsearch and Kibana, and then you can run the ed data stuff from there. SaaS or self-managed, we talked about that. Demo.elastic.co. If you want to play with it without installing anything, go to demo.elastic.co. We've got live data coming in. You don't have to sign in or anything. You can just click onto a dashboard and look at the data. You can go to the Discover tab and run searches on it, and get some experience that way. So questions. The folks in the chat have collected some questions for me. Building dashboards for Kubernetes environment. So there are, in your Kubernetes environment, if you're running Apache, if you're running Nginx, if you're running Redis, you'll see the exact same dashboards when you deploy a daemon set. If you go to the Elastic website and look at the container monitoring page, so if you go to the logging solution page and then click into, sorry, that's not live yet. So if you Google search for container monitoring, Elastic, and go to the container monitoring page, there are blog posts and videos and GitHub repos with examples to get you started, right? So the YAML files to deploy into Kubernetes. And you'll get all of the dashboards that I showed you, plus you'll get stuff that's curated for Kubernetes or Docker, right? So you'll be monitoring the Kubernetes or Docker environment and your applications all at the same time. I will paste the URL into the chat. Thank you, Jamie. And here is the URL for the container page. And oops, I put it into the wrong chat, didn't I? There you go, the container page, and you can go there. Can alerts also be sent via SNMP or REST webhooks? Absolutely. So the Elasticsearch has a RESTful interface, and you can use that. SNMP, there are Logstash and Beats plugins for SNMP, so you can use that also. Kubernetes I talked about. Sizing. So there's a sizing question here. So sizing depends on the use case. Are you using Elasticsearch for storing long-term logs and metrics? Are you using it with machine learning? It's very use case specific. So go over to discuss.elastic.co and ask questions there, and it's a great place to go back with the developers and with the community and talk about the specifics. So there was a question for the developers about incorporating contributions. I can just speak from my experience, right? I watched the Discuss forums for ingest for Logstash and Beats because I work closely with those teams. And when someone asks a question and they have a great idea of how to do something, there's always a developer that says, "Hey, how would you feel about creating a PR for that?" And we have guidelines how to contribute for Beats, for Elasticsearch, for Kibana. So go to the contributing markdown pages in the different repos and follow those instructions. And I think you'll see that you have good support from the developers for getting your stuff in. We love our community. So if the PR that you want to submit does a great job, and you submit the test cases and the docs, then I think you'll see that we're going to love you for it. If you go to Elasticon, you see a wall full of the names of the contributors who have contributed code. So, does MetricBeat or FluentD have modules for collecting OS info? So AuditBeat is going to have that soon. I don't know when. And in FileBeat and MetricBeat, you can turn on adding host and cloud provider and Kubernetes and Docker metadata, depending on where you're running things, and get lots of great information there. And we're at the top of the hour. I really appreciate you coming. On the slide that I showed a minute ago, we have, we mentioned discuss.elastic.co, demo.elastic.co, the community page. You can reach us on Twitter at Elastic. You can reach me on Twitter at Dan Rosigno. You'll see that on one of the slides when you download the slides. And thank you very much for spending some time with us today. Have a great day.